Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to yet another video on my channel, especially for grade 10 elite students who are going to give their exam very soon. So I bring for you today part 2 of the multiple choice questions that are going to help you for your coming exam for term 2 for math. So let's get started in the video. So these are the learning objectives as mentioned in the end of term coverage document that has come for grade 10 elite. For part 2 we are going to be covering these questions from the following page numbers. The first set of questions from lesson 6.1 logarithm and logarithmic functions that were there, question 1, 2, 3, 4, 5 and 6 have already been covered in the last video, so make sure you watch it in case you have any doubts. And now we are going to move to question 13, 14, 15, 16, 17, 18, 19, 20 and 21. So the method to solve all of these questions will be similar. Here you have to evaluate each expression. So when you see the word evaluate, it means you have to find the value of the expression. So all of these are logarithmic expressions. So the step that you are going to take is to make this equal to a variable y. Okay, and then you are going to use your exponential function to find the value. So this value that you need to find, you keep it as y, and then apply your knowledge of exponential functions to solve it. So the knowledge of exponential and logarithmic functions tells you that if you have a log base bx equal to y, then you can convert the log to exponential in the way that you take the base raised to the power y and make it equal to x. Okay, so this is what is the conversion from logarithmic to exponential. So that is what I'm going to be doing here. I will change the color. So when this expression is going to be converted to exponential, it will become base 2 to the power y equal to 64. Now I want to make the base equal on both sides, so I'm going to write 64 as 2 to the power 6 or with the same base. Now that the bases are equal, we apply the property of equality of exponential function to say that the powers are also going to be equal. So your y is going to be 6 here. In a similar way, you can solve these problems again by converting to exponential. So the base is 27, y equal to 81. Now the bases on both sides are different, so we are going to make them same with the common base of 3. So I can write 27 as 3 to the power 3. There's already a base power y, and then 3 to the power 4 is the way I write 81. Now you can apply property of equality for exponential function to say that the powers are going to be equal. So the power here is 3y, the power here is 4. So 3y is equal to 4 will give you y equal to 4 by 3. So here you have a fractional value. In a similar way, you can solve the other questions. Let me do a few more for you. So here the base is 100. So base to the power y is going to be equal to 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5. Now I can write both of them as a base of 10. So this is going to be 10 to the power 2y equal to 10 to the power 5. So the powers are going to be equal and y is going to be 5 by 2. Okay, let's do one more here. That is the decimal one. So I'm going to solve it here. Answer 18. So again I convert to exponential. So 10 to the power y is equal to 10 to the power. Now here it's a very small number, less than 1. So 1, 2, 3, 4, 5. 5 power with a negative sign because it's less than 1. So now I'm going to make the powers equal. So y is going to be minus 5 here. So it's a negative answer. So that's how you solve. I'm going to now show you the answers of all the questions from 13 to 21. So let's check our answers one by one. As I already explained you, the value for question 13 is going to be 6. So this is the value of y. For question 14, it is going to be 5 by 2. For question 15, it is going to be 4. For question 16, it is going to be 4 over 3. That's a fraction. For question 17, the answer is minus 5 by 2. For question 18, it is minus 5. I've already explained you in the last slide how this minus 5 comes. Especially again for question 19, the answer is 3. For question 20, the answer is 0. And if you see, everywhere we are following the same method. We are taking the definition of logarithm, converting it to exponential, making the bases equal, comparing the powers, using the power of equality for exponential function, and giving the value of y. So I hope you've understood the method. So if they are going to change the numbers also, if you understand the method well, you'll be able to solve the question. Next we move on to the lesson of common logarithms. So here question 9 to question 14 will be solved by using the property of equality for logarithm. So we are actually going to do the opposite that we just did in the last question. If you see carefully in question 9 to 14, you are given exponential forms. You are going to convert it to logarithmic form. You are going to take log of both sides and apply the property of equality of logarithms. So I'm going to write here, this is going to be solved using property of equality for logarithms. So that's what you are going to do. So you'll take log of both sides. I will just show you in the next slide the steps for getting the answer for question 9 to 14. And then from question 21 to 26, you have to express each logarithm in terms of a common logarithm. So common logarithm, that means we have to apply the change of base formula. So all of these questions from 21 to 26 will be solved using change of base formula. So some of them will give you decimal answers, and definitely for this question you would require a calculator so that you can put in the values for log and get your answer. So let's see the steps now in the next slide. Okay, let's solve question 9 first. In question 9, you are given 4 to the power 5k equal to 37. So we are first going to apply log on both sides. So I take log of 4 to the power 5k is equal to log 37. Now I will apply the power property of logarithm. So because the power is there and log is there, so when log is applied, the power comes down. So this power 5k comes down and it becomes log 4 equal to log 37. Now we need the value of k, so we are going to divide both sides by 5 log 4 and then put the value of log 37 and log 4, use a calculator, divide the two, and your answer for k will come out to be 0.5209 approximately. In a similar way, we can solve question 10. You take the log of both sides, then apply the power property of logarithm. Power comes down. You need value of p, so you are going to divide log 50 by log 8. Use a calculator, get your answer in decimal, and approximately it is going to be giving you 1.8813. So again in question 11, similarly in question 12, question 13 and question 14, if you see, we are applying the same steps. We are applying the log on both sides, then we are doing the property of equality of logarithm, then applying the power property of logarithm, then dividing both sides with the log, using a calculator and getting the approximate value. Now out of all of these questions, I feel question 12, 13 and 14 are very important, so you need to understand the steps well. The steps are quite similar. The only thing that will be added here is the distributive property. So let's do one of them. I'm going to do question 12. 13 and 14 are similar. So here, this is the equation given to you. First step is same, you apply log on both sides. Now when you apply log on both sides and there is an exponent with the power comes down. That's your power property. So 4x minus 2 comes down. And here comes the extra step of applying the distributive property. So 4x is multiplied to log 5 to give you this. and 2 is multiplied to log 5 to give you minus 2 log this. Now if you see, log and log is there, and here is log 120. What you need is the value of x, so you are going to isolate this term here on the left and move this log on the other side. So it becomes log 120 plus 2 log 5. Now put the values of the log, divide each side with 4 log 5 because you need the value of x. So you are going to move 4 log 5 on the other side and divide. Now put the value of log 120, log 5, simplify, use a calculator, and this comes out to be approximately 1.2437. So accordingly, similarly, 13 and 14 will be solved. The steps are shown here. Now we are going to solve question 21 to 26, and as I told you, we are going to use the same formula, change of base. So what does this formula say? Let me give you the steps. So here log to the base 422 is given. So this can be written as log 22 divided by log 4. This is the change of base formula, and then you can use your calculator to get the value of the individual logs, divide them, and get your answer like this one. So again, this is going to change as log base 12 200 equal to log 200 divided by log 12, and this is called the change of base formula. Very simple. You can then use a calculator to get the values of log, divide them, and get your answer. Similarly, question 23, 24, 25, and 26 can be solved. If you see, there is a minor difference in question 26 because it has a decimal here already. So nevertheless, the value or the steps are not going to be different. You have to again apply the change of base formula, and this will be equal to log 5 0.4 equal to log 0.4 divided by log 5. Only difference is the value comes out as negative. Okay, now we are moving ahead to using exponential and logarithmic function, lesson 6.5. Now these are some very important word problems. We are going to be using the formula y equal to a e to the power minus kt. This equation is called the continuous exponential decay. If you see the words decay and decay constant, and here also if you see carefully, decay constant, all of these words are mentioned. So that's the hint for you that you have to use the continuous exponential decay equation, which is this. Now what are these variables? Let's understand. First of all, k is the decay constant. So this k is the decay constant. T is the time taken for the decay. A is the initial amount, the amount with which we start with. And finally, y is the amount which is left after the decay has happened. So if you see the first question, question number 3, determine the value of k and the equation of decay for this radioactive substance, and it is a question on half-life. Half-life means it's the time in which the amount, especially the amount of this radioactive substance that is given, has reduced to half. Okay, so half-life means the amount is reduced to half. And how much is that half-life? That half-life is given to be 32 years. So this is going to be the value of t. And if you see, the amount which is left after 32 years is going to be half of it. So we know that in this equation, y equal to a e to the power minus kt, your y is going to be 0.5 times a, which is half of the amount left. T is going to be 32, and then you can simplify the equation using the property of equality for logarithmic equation, as you would see in the next slide when I show you the steps to get your value of k, the constant of decay. And after you get the constant for decay, you can put its value in this equation, y equal to a e to the power minus kt. And for part B, we will be getting our answer using that equation, and a little bit of calculation on your calculator is going to give us the result. Again, for question 4 and 5, we are going to be using the same equation. And let's now go to the next slide and see how this continuous exponential decay equation is going to help you to get to your answers. Okay, so as explained in the previous slide, we are going to be using the equation for exponential decay or continuous exponential decay, which is y equal to a multiplied with e to the power minus kt. Now, if you see this question carefully, there is a half-life given. That means the time in which the amount reduces to half. So y is going to be 1 by 2 of the initial amount, or 0.5a. That is the amount which is left after the decay has happened. That is going to be a multiplied with e to the power minus kt. The half-life is given to be 32, so I'm going to substitute 32 here. So then you cancel a from both sides. You are left with 0.5 equal to e to the power minus 32k. Then we apply the property of equality of logarithmic equation by taking log on both sides. So remember, log e is going to be 1. So the right side reduces to only the power, which is minus 32k, and the left side is log 0.5. Put the value of log, divide by minus 32, and what you get is the value of k. So the rate of decay, this is the decay constant, that has come out to be 0.02166, or about 2.166% per year. Okay, if you convert into percentage. So you can write the equation now as y equal to a e to the power, put the value of k, which is negative t. Now b part of the question says how much of a 5-gram sample. So this is the value of a. A is 5, that is the initial amount you start with, should be left after 100 years. That means you put the value of t as 100. Now put all the values here. A as 5, k already we have substituted, t as 100. So multiply, simplify, and this comes out to be 0.157. So that means about 0.57 grams of the radioactive substance will be left after 100 years. So that completes the important word problem. Next, we move on to carbon dating. Here the decay constant is already given. You need not find it. K is given to be 0.00012, and use this information to determine the age of the object based on the amount of carbon-14. So there are two parts to the question. In the first part, you are given that it has lost 95% of the carbon-14, and in B part, an animal skeleton that has 90% of the carbon-14 remaining is there. So put everything on in the equation. So y equal to a e to the power minus kt, same equation we will use. I'm substituting the value of k, and we know that 95% is lost. So how much is remaining? Only 5%. So if you convert 5% to decimal, it is going to be 5 over 100. That is going to be 0.05. So you put in place of y 0.05 a. Okay, now a and a again khalas, cancel, take log of both sides like the previous question. So in all of these questions we are using the same formula. If you see, y equal to a e to the power minus kt, which is the formula for continuous exponential decay, and to simplify we will be taking log of both sides and applying the property of equality, saying that log e is 1 and the power comes down. Then simplify, divide, and this value for t comes out to be 24,964. So this carbon is so many years old. Let's do the B part. In B part, the animal skeleton that has 95% of the carbon remaining. That means only 5% has decay, 95% is left. So the value of y will be 95%. In decimals, it is going to be 95 over 100, which is going to be 0.95a. So that's what you put here, 0.95a. Then put the value of k already given, simplify, take log of both sides, apply the property of equality for logarithmic equation, divide by the number and get your value of t. So I hope with these two questions you have understood that we are applying the same method again and again for different numbers. Let's solve another problem on continuous exponential decay. We are going to use the same formula for solving. The only difference is in the numbers. So let's read the word problem and highlight important information. Archaeologists uncover an ancient wooden tool. They analyze the tool and find that 22% of the carbon-14 comparing to the likely amount that it contained when it was made. Given that the decay constant is this, so the value of k is given. How old is the artifact? That means you need to find the time. Okay, how many years old it is. And if you see, there is a percentage given, 22%. So this is given that 20% is sorry, 22% is the amount which is left. So you convert 22% again, like previous question, to decimals. So this is going to be 0.22a, and that's going to be your value of y. So put the value of y, put the value of the decay constant. Again, cancel a on both sides, then you take log of both sides. The power comes down, log of e is 1, divide by negative 0.0012, and your t, or the um, time for which the artifact is there, how old it is, has come, which is 12,618 years old. So that brings us to the end of part 2 video. The video was becoming very long, so I have covered one part of the video for part 2 here. I'm in the process of making another video for you for part 2, so stay glued to the channel. And if you have been watching my videos and liking the content but have not yet subscribed to the channel, I request you to please do so, as it serves as a motivation for me, and also press the bell icon so that you don't miss my coming videos. Stay glued for the next part of part 2, which is going to come for all grade 10 elite students at 6 p.m. sharp on my channel Mathematics Made Easy. Until then, this is Ms. Ruchika signing off from this video. See you in my next video. Bye students.